right, free response question number 4, no calculator. We don't need one. Find the equation of the line tangent to f of x at x equals 2 in point slope form. All right, so one at a time. The tangent line at any point, we have ourselves a line. I don't know exactly what happens at x equals 2. This could be completely off, but let's just make believe it happens here, right? If that is where x equals 2, the tangent line is some line that basically creates that slope at that moment. It's a snapshot of the slope at that moment. What we want is the equation of that line. So this is what we're going to do. We're going to take the derivative of this, okay? And then we're going to plug in what happens at 2, and that's going to give us our slope, okay? Now, once we have our slope, we know that x equals 2. In order to use point slope form, which is what they want, we need a slope and we need a point. This will give us our slope. We have half a point. So the other point is to take f of 2, and that will give us our y value. Once we have our slope, and we find out what happens at f of 2, and by the way, yes, f of 2, not f prime of 2. F prime of 2 gives a slope, f of 2 gives us a point. Once we have that, we write out our point slope form, which is y minus y sub 1 equals m times the quantity x minus x sub 1. All right? So those are our 3 steps. So let's take the derivative, plug in 2, and that will give us our slope. So this is just power rule, nothing. So f prime of x is going to be the derivative of x cubed, which is 3x squared, minus the derivative of 48x, which is minus 48x, plus the derivative of 3, which is nothing. F prime of 2 is going to be 3 times 2 squared minus 48, which is going to be 3 times 4 minus 48, which is going to be 12 minus 48, which is going to be, holy crap, negative 36. So our slope is negative 36. Okay, so that's part 1. Now so point slope form, we found our slope. Now I need to find our point. Our point, we have half of it, x equals 2. I need the y value, so let's plug in 2 into this original problem. So f of 2 is going to be 2 to the 3rd power minus 48 times 2 plus 3. So that's 8 minus 96 plus 3. And 8 minus 96 is negative 88. Negative 88 plus 3 is negative 91. No, it's not. Negative 85. What was I thinking? Negative 85. All right. So that's our point. So we have y minus y sub 1 equals m times the quantity x minus x sub 1. We have a slope at negative 36. We have a point at 2, negative 85. So if I were to label you x sub 1, y sub 1, we can put everything together. Y minus negative 85 equals negative 36, x minus 2. Cleaning this up is going to be y plus 85 equals negative 36 times the quantity x minus 2. Yuck, gross, no thank you. Now B here is asking us to determine all critical points of f of x. So let's do things one sentence at a time, because there's 3 things that this guy is going to ask us to do. So B is asking us to determine all critical points. Let's get rid of this over here. I don't need that. I'm going to need the space, and I'm going to probably want a new slide for C. All right, critical points exist when your derivative equals 0. So I have my derivative. I found that out. So let's set that equal to 0. 0 is equal to 3x squared minus 48. We can factor out a 3, and that leaves us with x squared minus 16. Okay, now let me move that up here. 0 equals 3 times, oh, wait a minute, I know what that is. That's difference of squares. Oh, that's much easier. So my critical points are going to exist when x is positive 4 and when x is negative 4, because those are the numbers that make those factors 0. 3, who cares? So those are my critical points. Identify the intervals where f of x is increasing and decreasing. Well, this is going to be pretty easy. The graph here is a positive leading coefficient cubic, which means it's going to look like this, right? I call this the Drake cubic because it starts from the bottom and now it's here. I know Drake's kind of a sensitive topic lately, but you know what? I'm leaving it. Anyway, if I write out a sine graph, knowing very well that my critical points are 4 and negative 4, okay, I'm going to have a sine graph at negative 4 here and positive 4 here. And this is the sine graph for the derivative, which is going to be f prime. Now, what the critical points give us is where the slope equals 0. When I say, let's take the derivative and set it equal to 0, that's me finding when this slope is 0. So you are a critical point and you exist at negative 4. You are a critical point and you exist at positive 4. Which means if your critical points, anything that is not a critical point is either going to be increasing or decreasing. So here you are increasing, you hit a maximum, then here you are decreasing, you hit a minimum, and here you are increasing forever and ever and ever. So the intervals where f of x is increasing is going to be 2 of them. Okay, the increase exists from negative infinity to negative 4 union 4 to infinity. That's where we're increasing. My decreasing is only once, and that happens from negative 4 to 4. So still not done the problem yet, because now I need to classify all local extrema. So what I'm going to do is not only am I going to just say, oh, okay, well, local extrema is we have a maximum at negative 4 and a minimum at 4. I'm going to find out what those points are. So my maximum exists at negative 4. So that means we're going to plug in negative 4 into the original function to get us the exact point where this happens. So that's going to happen at negative 4 cubed minus 48 times negative 4 plus 3. So negative 4 cubed is negative 64. Minus 48 times negative 4 is going to be 192 plus 3. So 192 plus 3 is 195. 195 minus 64 is going to be 131. Okay, so that tells us that we have a maximum at negative 4, 131. And that, let's be specific, that is a local max. You know what they call it? They prefer relative in calculus. So you have a relative maximum at that point right there. Okay, circling all of the answers that I came up with so far. All right, so I have a relative maximum at negative 4, 131. To find my minimum, I'm going to do the same thing but plug in regular 4. So f of regular 4 is going to be regular 4 cubed minus 48 times 4 plus 3. So that's 64 minus 192 plus 3, which ends up being negative 125. So that's my relative minimum exists at the point 4, negative 125. All right, so we conquered all the beasts of part B. Okay, part B, determine the critical points. There you is. Identify the intervals where f of x is increasing or decreasing. There you is. Classify the local extrema, also known as relative extrema. There you is. There you is. There you all is. All right, now part C, and we're going to move to a different slide in this, is going to ask us to find the area enclosed by f of x in this brand new g of x. Okay, so we're going to have two functions. You have this cubic, you have this line, and they're going to intersect somewhere, but that's great. However, what's nice is they're giving us two lines. These are going to be our limits of integration. To find the area of a function, you use integration. Now, if you're going to do two functions, what you're going to do is you're going to take the integral, lower limit, upper limit. You're going to do f of x minus g of x dx. Now, here's the thing. I don't know which one's on top. I don't know which one's on the bottom. I mean, according to this picture, it looks like the linear guy is on top, so whatever, who cares? If I get a negative answer, I'm just going to take the absolute value of it, make it positive, and I'm not going to lose sleep. So the integral that I'm going to write out is going to be the integral from regular 1 to positive 2 of f of x, so x cubed minus 48x plus 3 minus g of x, which is going to be minus 55x minus 3. Close it, dx. So that turns into the integral from 1 to 2 of x cubed. Negative 48 minus 55x is going to be negative 103x. 3 plus 3 is 6. Okay, now I can integrate. The integral of x to the third, and let's move that up here, is going to be 1/4 x to the fourth. The integral of negative 1 over 3x is negative 1 over 3 halves x squared. And the integral of 6 is 6x. And my limits are 1 and 2. So we're going to have gross math here that we're going to have to deal with. It's unfortunate, but it is what it is. Okay, so I have, let me make sure I have enough space. I don't know if I did a good job with that. 1/4, 2 to the fourth, minus 103 halves, 2 squared, plus 6 times 2, minus 1/4 times 1 to the fourth minus 1/3 or 103 halves minus, let me make that minus sign much clearer than it is, 1 squared plus 6 times 1. Okay, so 1/4 times 8 is 16, it's a close one, minus 103 over 2 times 4 plus 12 minus 1/4 minus 103 over 2 plus 6. So you become 4. You become minus 206 plus 12. If we combine these into one big fraction, I don't want to do it. I don't want to do it at all. Let's just do decimals. 0.25 minus, what would that be? 51.5 plus 6. All right, that first bracket, negative 208 plus 16 is negative 190. You become negative 45.25. Double negative becomes positive. So now we're looking at negative 144.75. So I did it backwards. No big deal. Our final answer is just make this guy positive. And by making it positive, we end up with 144.75. Yuck, yuckity, yuck, yuck, yuck. But that's it, and that ends free response question numero tres. No, number 4. Oh, yeah, I don't want to go backwards. A couple more to go, and then we're done this thing.